Now. Alrighty, looks like we're live. So once again, as I always say at the beginning, for anybody watching on the replay, please like and subscribe. If you have any questions, comments, or ideas. Oh wait, I say that part at the end. But yeah, so this will be a pretty straightforward stream today. And I really gotta make more thumbnail images, but today we're gonna use something generic. We're going to use the late show. There we go. Because this is my regular Monday show. And so for anybody tuning in on a replay, keep that in mind that, you can catch me Monday evening around 10:30. It looks like I've been consistently doing 10:45. So I might just make that the permanent, dead set time for like all of my Monday shows. Just say Monday at 10:45 because it seems I can consistently deliver on being around for that one, right? So yeah, that's where we're at. But right now we're just gonna open up some browser tabs and get lit up, and hopefully we get some of our usual people here, because I gotta my stream deck is being rude. Hey, what's up there, JLM? So I think the USB hub in my monitor died. I'm like 10% sure that the USB hub in my monitor is dead. I'm only 10% sure right now, but I see this as evidenced by the weirdness about the way my monitor's built-in USB hub is behaving. Basically, I am late, but that's only because I didn't commit to the 10, because I've been saying 10:30. But you're gonna see the screen go black for a second while I go and unplug my stream deck, because I'm tired of this stream deck. Well, no, it's not the stream deck. I'm not blaming the stream deck. I don't even know which camera. Did I unplug the wrong camera? I don't even know what I just did. I mean, I have a vague idea. Okay, good. My desk camera still works. So I unplugged the wire for the stream deck, but apparently this wire is super taut. Like, I cannot fish it out. Oh yeah, there we go. All right. So, I guess we got unplugged the monitor's USB hub. Did I just unplug my camera? No, I did not. So that's a real bummer, because I wasn't trying to have like, a pain in the butt. But it looks like this weekend, when I'm off from work, I'm going to have to troubleshoot the USB hub in my monitor, because it is up to no good. It is not cooperating, I'm 100% sure people are getting stranger. So let's see here, just get a little adjustment here, and we got a special treat right here. Not really a special treat, but I'm gonna get it queued up because I basically am gonna start with a reactionary thing today. Yeah, we're gonna do a reaction. We're gonna react to this mother effer right here. His name is, oh my god, funny story. So, whoops. So anytime I reboot my computer, not every time, but every other time I reboot my computer, the monitors get reassigned to like different numbers. So it's like I always have to tell the computer where monitor number 1 is. Not always. It's like every third time, which is like, I wish it was every time, because then I would anticipate it. But hey, it gives me a little bit of time to get people in the chat, hopefully, right? Some other people. I mean, you're good company. JLM, but let's see here. We're gonna get this show on the road regardless of who shows up. But first things first. Okay, good. I got monitor 1, monitor 2, and monitor 3 is like not assigned correctly. So I'm gonna fix that right now. But it's like, it's really easy to fix if I anticipate it, and it only happens when I reboot my computer. It usually doesn't happen if I sleep mode my computer or hibernate it. I recommend body armor and medical training, or move away from people. That is a good solution to a lot of problems. So, anyway, let's try that again. We gotta turn off studio mode. And now we can see the monitor. Because I just wanted to make sure the Chrome browser window took up a little bit more screen real estate. I mean, like, I'm getting my money's worth. I might as well, make sure everyone's getting my money's worth on the size of the screen here. Unless, of course, we want to make it so that you can read the chat. Because I gotta say, the chat definitely looks easier to read against the star field. So let's get this show on the road here. I said that twice already, but you know, I'm sure we're all 5x5 here. And yeah, I got a comment from JLM saying hi. I think it's because you probably said hi to me in the comments instead of the chat. I do that sometimes. But anywho, I got a special playlist here, and really there's only one item on the playlist that matters. Actually, we got a rabbit hole, we got a topic, and we got low spec Linux laptops video, which I plan to comment upon. So anyway, let me just get some audio here lined up. See, that's what I probably should have done before the stream. But anywho, we're gonna just get that taken care of now. So I just gotta tell the computer. There we go. And hopefully this don't blow up our eardrums. Be ready to blow out your eardrums. So we're gonna react to the opening sequence to the 1980s episodes of Computer Chronicles. This is a TV show that was on basically PBS in California, and it was ultimately syndicated or mailed out on, you know, probably quarter-inch cassette tape or whatever they were using at the time. It was mailed out throughout the country and broadcasted even on my own local PBS station, which is where I discovered this show. Now, I didn't discover the Computer Chronicles until like the mid to late 90s, and those episodes give me a certain sense of 90s nostalgia, but this is a bit before my time. I was born in 86. This is October 83, but I like this episode a lot, and I think it covers a lot of like relevant computer history. I mean, the title of the episode is Mainframes to Minis to Micros, and it's like it's a snapshot of what people in the field thought about these technologies in 1983. And so, in a nutshell, you know, we know PCs today. PCs are microcomputers because they use microprocessors. You know, like there was that time I did a stream where I showed the processor chips on my desk. Those are microprocessors, and here we go. And before you had a microprocessor chip, and they come in many shapes and sizes, but this is pretty standard fare. Hey, what up? Hey, what up? That girl Casey is here. Hey, it's good to see you. Give a shout out. I'll even drop a link to your channel, JLM. Actually, I'll get the link right now because I can click on it real quick. But I do want to shout out Casey, and you know, I recommend you check out her content. She has some really, you know, fiery content. Just, I think, well thought out. I really enjoyed the Pat Buchanan video today, and had a heated discussion with my father over dinner about it, even though he's like pretty much a fan of Pat Buchanan. He introduced me to the friggin' guy, you know? But like, anyway, you know, he actually believed in the baby's heads getting chopped off. I was like, dude, we talked about this 2 weeks ago. Even an Israeli dude I spoke to was like, this is propaganda, and he's like gung-ho about the whole, you know, flattening. Anyway, so don't want to go down that rabbit hole right now, but we're gonna say subscribe to that girl Casey. There we go. And there we go. All right, damn it, I misspelled that shit. Forgive me. All right, so let's get the show on the road here. So we're gonna go back in time and talk about, like I said, microcomputers. Every PC is a microcomputer because it has a microprocessor in it. And before you had microprocessors, I would say we had what I would coin a macro processor. That is not the correct term because macro would actually refer to like a program that it's like a script, a macro. You can write macros in Microsoft Word to automate tasks. But macro, like in that Star Trek Voyager episode when they had the macro virus. And basically what happened was there was this thing. It started off as a virus that was microscopic, and it ended up looking like a bunch of little fruit flies coming out of the alien's skin. And it turned out, like, by the end of the episode, Captain Janeway is fighting these things that are, like, this freaking big. And, of course, it was, like, fictional, you know, I mean, this is not realistic at all, but I appreciated the concept, because it, like, explored the idea, like, if you take something on a microscopic level and just keep it the same, but make it large, what do you get, you know? And so, essentially, if you go back to 1970s to the 1970s or 60s, this is in a box that's bigger than a desktop computer. It's like, that is because, you know, if you look at a picture of a microprocessor, it looks like a little city. It looks like, you know, like, for example, we got like should we get a good photograph? Yeah, like all of these pictures are great examples. So, you know, just essentially every part on these diagrams, unfortunately, these are more modern multi-core CPUs, but in a single core CPU, it's a much simpler, like, it's like just some discrete components, and like this part is like multiplication, this part does addition, this part does subtraction, and so all these different parts do things. These are like the beads on an abacus, because an abacus is like an early computing device. These are literally like the beads of an abacus, and each of these, like, there's diagrams where they label everything, and like sort of like the diagram we saw on the earlier page where like it literally says like 32 megabyte, you know, L2 cache. This says the video chip is over here. The decimal stuff where it handles decimal numbers is over here. Apparently on a Mac CPU or a system on a chip, the Thunderbolt ports all get mapped to this area here. But in the early days, you didn't have all these components on one chip. In the 80s and the 90s, all of these components would be on separate microchips. So when you take a motherboard out of a computer, you got like separate chips, and at some point, they put them onto one chip. But before that, you had this and a bunch of other chips, and this chip alone was a box this freaking big. So let's get right to the topic at hand. So we're gonna just react to the opening of Computer Chronicles. Hopefully the sound works. We're gonna skip past the countdown. And I'm gonna skip back a little bit, but I just want to share this. So that's a microprocessor right there, of course, circa 1980 something. So real quick, I want to just circle back. So you even got like this Chinese guy with some early abacus, and you got some like, what are you, medieval guys doing some mathematics here on an early computing device. Then you got some mechanical shit. I think that's like Charles Babbage's machine. It's like just a series of gears that allow him to do multiplication. Then you got like one of these weird mechanical adding machines from the frickin' 40s or 50s. And then right here, we got punch cards. And this is kind of like relevant, more relevant today. So punch cards are sort of like floppy disks as we remember them in the 80s, or flash drives today, except that each punch card would just have like enough for like maybe like a few pieces of text. And you would have a card this big, and you'd have like rows of places where you punch holes, and you could literally use a hole puncher to manually punch holes in the card, and like you'd have like 10 10 10, and you get like a letter A, B, C, D, let's say. And if you combine stacks of punch cards, you get lines of code. It's like literally like you could have a Word document. You could have if you wanted to, you could store a love letter or a text document in a stack of punch cards. Although typically it was used for code because computer storage was limited. And not everybody could get access to a computer terminal at the same time. So it was like, okay, go to your dorm or go wherever the hell you are and, you know, punch this up manually. And they did have machines that were like typewriters where you would type out the code and it would make a punch card. There's all kinds of ways to do this type of thing. But bottom line is this is like an early form of storage media that was prevalent up through the 80s. And like essentially they're scanning them, they're reading these, and they can take these punch cards and turn them into a file that can then be put onto a disk. And actually that's what they would do. They would put them on 10-inch floppy disks, or they put it on a tape drive that would be like, it looked like an audio recorder. It'd be like 2 reels of tapes. And early hard drives, going back to even the 70s, you had hard drives that like, you know, this big. It was like, imagine a machine the size of a washing machine, you know, like a laundry machine. But on top of it, you got this little pod where you put disks in. That was like a 40 megabyte or 100 megabyte disk. So, you know, if you're a university student or something, you'd be playing with these and tapes. If you were an insurance company, you'd have a room full of disk packs, and these were early hard drives. And we can go back to the early IBM 5 megabyte hard drive, and I think we could touch on that real quick, because this here is the IBM 305 RAMAC, Random Access Method of Accounting. You see that right there? So this little thingamajig here was literally just like a hydraulic piston. And instead of having read-write heads on every platter, you'd have like a stack of hard disk platters, and this little thing would move the pickup up and down in order to find a file. And to make the whole bloody thing work, you had to have this freaking shit right over here. I mean, look, you got the hard drive here. That's all of 5 megabytes, which 5 megabytes is actually 5 million letters or something like that. It's like basically 8 bits makes a byte. 1,000 bytes is basically a kilobyte. So, you know, 1,000 kilobytes would be 1 million letters. And I mean, I'm simplifying it a lot. I'm oversimplifying the shit out of it. But that's what we're dealing with there. And, you know, even this, just being able to have a central place to store data would make it easier to do calculations, to say, okay, we got a bunch of data for an insurance company, or we got to take this database and figure out how many square feet of space we have based on all of the data that we collected over the course of a year. And whatever it was. So anyway, let's keep going here. And you can even see, there we go, there's a tape drive. And tapes were good because they got high capacity for cheap, but you couldn't just randomly read data off of them. Like on a disc, you could randomly access any file. On a tape, you'd have to rewind the tape to get to a file that was stored earlier in the tape. And so generally, as I understand it, you would have to be able to dump the entire tape onto a storage device, or you would have, let's say, something in your RAM, something in your temporary memory that you want to dump to the tape for permanent storage. And there were a number of reasons you would do that. But real quick, let's get to our chat real quick here. So yeah, you know, it is definitely some throwback material right there, Casey. And something about rogue white blood cells from my friend JLM trying to conceptualize external... Oh yeah, dude, that's a whole rabbit hole on its own. Like one day maybe we'll talk about that Star Trek Voyager episode. I think Montgomery Ward... I think the Montgomery ward I worked in had an ancient IBM mini computer sitting somewhere in the closet. Oh, perfect. We're going to touch on mini computers. So far, we just looked at mainframes, basically. And I didn't even talk about what a mainframe is. I'm actually going to rely on this episode to do that. That would be the nerdiest thing ever. A love letter on punch. Yeah, tell me about it, right? That would be absurdly nerdy. It's quite a bit of information. Also, is it just me, or is it all software bloatware? A lot of it is, but also... the user friendliness alone does use up a lot of memory. Alright, let's get this show on the road here. Oh, and the guy that they stole DOS from, he's in this episode. The guy that Bill Gates stole DOS from, in so many words. He didn't exactly steal it, I'll get into that. The guy sitting on the right is Gary Kildall.
Welcome to the Computer Chronicles. I'm Stuart
Creator of
Chaffee,
CPM.
and this is Gary Kildall. On today's program, we're going to be looking at the evolution of computer hardware, from mainframes to minis to
Unlike Bill Gates, he's actually a decent guy who cares about his craft.
micros. We'll see some examples of the oldest mainframe computers, and we'll take a look at one of the newest microcomputers, the HP 150 from Hewlett-Packard.
DOS is a result of that man's work.
At the end of the line in the
Gary is the reason DOS became what it was by the time we were in high school.
Evolutionary process still to come.
Well, fortunately, we're obviously not at the end of the line. We're at some point in time in the evolution of using, say, microprocessors as general-purpose computers, and they're just getting smaller, faster, less power, and most importantly, they're less expensive than they ever have been. I guess the logical conclusion is they get so small that you lose them like you do your keys. But as far as evolutionary trends, there are a lot of new things happening with microprocessors, use of microprocessors as controllers for, let's say, intelligent devices such as a wheelchair that finds its way around and, under microprocessor control. So I think there's a lot of exciting things that are going to happen that will be off the mainstream of using computers as general-purpose computers.
This guy was really passionate about it back in the day.
Okay, to start our look at the evolution of microcomputers and mainframes and minis, we went to Boston to visit the Computer Museum.
Established in 1979, the Computer Museum houses the most extensive collection of early computers in the world. Its galleries feature some of the earliest known calculators, like the Pascaline, invented by the French mathematician Blaise Pascal in 1642. The Pascaline stored numbers on 10 little rotating dials. Moving one dial up to 10 moved the next dial one notch, and so on. It was the first consistently reliable example of a computing machine.
BAT file is programming.
In the late 1800s, Herman Hollerith devised a card punch calculator to speed the tabulation of the 1890 census. The cards were hand punched, but electrically read,
a form of a language.
Concept that showed up much later in the earliest IBM machines and is still used occasionally today. The forerunners of modern computers didn't appear until the late 1930s and 1940s.
So this is like a hard drive,
of which only a few parts remain, was a massive machine.
It's a hard drive, but it's really not, because like you just have, instead of having multiple disks, you have this drum-shaped surface is where all your data is written. Instead of having a read-write head that can move side to side like a needle, these little pickups are all used at the same time. So it's a little confusing how it works, but I mean, it's a simplistic lower capacity hard drive, but the point is it allowed like higher capacity storage that could be randomly accessed instead of dealing with a stack of paper cards or rewinding a tape.
Covering 3,000 square feet and weighing over 3 tons. The heat given off by its 18,000 tubes required constant monitoring, and in spite of its great mass, the Whirlwind's processing capacity was about the same as a present-day 16-bit microprocessor. It was not until the invention of the transistor in 1947 that a new era of smaller, more efficient computers became a reality.
There's an episode of this show about Terminate. So regarding Terminate and Stay Resident code or applications, yeah, so basically the idea was that in DOS, you couldn't open multiple apps at the same time, but if you had an app that supported Terminate and Stay Resident, it meant that you could be like in a word processor typing a Word document, but then if you press like Control F10, it would open up a calendar, let's say. And so it wasn't really multitasking, but it gave a sufficient illusion of multitasking. And I think the episode about that is a little bit later, but it's in the early to mid 80s.
World's first general-purpose computer using transistors. And it still works. We'll see a demonstration coming up next.
So right here you see someone winding up paper tape. And this is relevant because even the early versions of BASIC, when Bill Gates, that cunt, pardon my language, was doing his thing, it was on paper tape. Because back then, if you didn't have a floppy drive and you didn't have a hard drive,
the TX0 was...
you would use a teletype, which is a typewriter that you would use for sending text messages over a phone line, and they would use these extensively in business and in the government and in the military. In fact, they had teletype machines on the World War II submarines, basically, where they could send text messages over the phone lines or the radio waves. But, of course, Western Union, being the messaging company of the era, they somehow needed to temporarily store the messages before they could transmit them. So maybe I would say, send this message out, and some person at Western Union would type it out and create a piece of tape. Then they would take that tape somewhere else in the building, and they would put it in the machine that would transmit that message, basically, in an automated manner. So now it's like you don't have to retype it again, basically. What's up, Lady Mist?
Was an experiment in transistorization, the first solid-state general-purpose computer. Its transistors were encased in little removable tubes so that they could be easily checked. Designed and built at the Massachusetts Institute of Technology in 1956, the machine used a modest 5,000 watts of power. Punch tape served as an input device, rewound by hand after each use. Although the machine was transistorized, it was and still is very sensitive to heat and will only run if the temperature stays below 80 degrees.
What the hell? There we
video
go.
Game program.
Oh yeah, he's playing a mouse in a maze game.
Involving a mouse with a memory, threading its way through a maze.
I will touch upon the alien spacecraft and transistors thing in a little while.
To reach a piece of cheese.
Yeah, hit that like button. Thanks, Casey. So it's like he's using a pen to interface with this absurdly weird computer, and they got a little mouse on there. How cute. Makes all kinds of weird sounds, though. Kind of cool.
TX0 was built at...
Oh my God, there's a swastika on there. I don't think that was intentional, but that I shouldn't be focusing on that. But that is a incomplete, you know, them guys. You know, that's one of those guys' symbol.
And the notion was
total accident, but kind of funny.
One was transistorized circuitry, and the second thing that it was designed to do was
this guy was kind of a big deal back in the day.
Memory.
What up, Lorenzo? Speaking of Lorenzo Sleestack, I did a presentation about the man who should have been Bill Gates, Gary Kildall. I did a little presentation on Lorenzo's stream once. It was a fun time.
Really was a circuit tester and a memory tester.
Displayed in the Computer Museum's lobby are some of the biggest solid-state machines ever made.
Subscribe to Lorenzo Sleestack. He does open streams almost like every week.
6600 and the ELIAC 4 represented the most powerful class of computers of their 100.
Control Data 6600.
The IBM Stretch, Control Data 66.
That was created by the guy who made the Cray supercomputer. The Cray supercomputer, the first one, was actually used to make some of the scenery for the movie Tron. And yeah, these were like actually not just mainframes. the Control Data Corporation computers, some of them were like literal supercomputers of their era, used for very specific stuff. Some of them were purchased by CERN at the time. I don't know what they did with them, but they used them apparently.
600 and the ELIAC 4
began with some ideas in the early 60s.
Skip that guy.
Development of integrated circuits paved the
right
way
there. So you got paper tape going right through there. So this is a thing that's either reading or writing the paper tape.
for faster, smaller, more powerful.
And this is looks like a PDP-8, maybe earlier. It's one of the first mini computers, and we'll get to what that is eventually.
And the mini computers of the 1960s.
So basically, mainframes were these big monolithic machines that, you know, an insurance company would own. That, you know, some corporation, the city of New York, you know, municipalities. And mini computers would be more like the math department or the computer science department to some university would want to have a computer. So whereas a mainframe would be like something that might be possessed by an entire city or corporation, a mini computer would be more like almost like a server, actually. And so just like today, you could have a server where multiple people can log into the same server and, you know, use it. That's what you do with mini computers. What up, QEPX? We're going down memory lane.
Small in those days bears little resemblance to what we call personal.
And so a mini computer back then was still big, but it's like instead of having a computer that took up multiple rooms, a mini computer would only take up like 3/4 of an entire room. So, you know, that was considered a pretty good bit of progress.
Today,
some people consider this Link computer to be the first truly personal computer. It has a keyboard.
He's got it.
It has a CRT. It even has mass storage devices.
Tape.
But this part was only the terminal. This, in fact, was the computer. And in the days of this computer, this was considered portable because it was on wheels.
It's a portable computer?
mini computers were a major...
Right there. Digital Equipment Corporation, PDP-8. This is the company that pioneered the mini computer. And the PDP-8 was revised multiple times. So even when they had the PDP-11 out or PDP-10, they had more compact versions of this. And what I want to direct your attention to are these little orange and white switches here and these lights. And basically back then, when you turn on the computer didn't know what the hell to do. It didn't know where the keyboard was. It didn't know where your tape drive was. It didn't know where to put memory or anything like that. So you would literally flip these switches like you were doing on, off, whatever, right? Binary code or machine code or assembly code. The lights would blink in a corresponding manner. And one of these switches would basically say load. So you'd basically say, okay, here's the data I want to feed it into the memory. And then this switch would be like, put it into the memory. And that would just be like one set of code. So essentially, computer code of that era was sort of like an orchestra. And so you'd have like this line of code, it would do nothing on its own. But if you took this line of code and went and like had enough code, eventually this block of code would do something meaningful. It might say, oh, yes, there's a disk drive over here and you should access it on this memory address. And when you read stuff from that disk, put it into the RAM on this address so that later on I can tell programs to use that address, sort of like a street address, but inside of a memory chip or a group of memory chips. But, you know, this was like one of these days I'll share a video of how that went.
Breakthrough equaled only by the appearance of microcomputers in the next decade.
Yes, absolutely,
Progress in very
JLM.
large-scale integration.
Some of these machines were used well past their obsolescence due to extreme expense.
Increased processing capacity.
They were still good for education.
But the future holds more than just a change in the...
In fact, right there, see that picture we're looking at? This is a picture of a microprocessor, just like the thing I was holding before, right? Like this old 486SX. And if you look under this gold plate, you're going to see something that looks a lot like what we're seeing here. And see these little pins here? So the early microprocessor would only have like 10 pins, let's say. This is a 4004, which predates the 8008 and predates the 8086, which is like 3 generations before this guy here. But these little golden pads here is where they would run the wires, because essentially you'd have the processor here and there would be these little golden pads along the edge of the thing. They call it the CPU die, and they would have to run micro wires made out of gold from those little pads to these little pins, and that's how it connects to the computer basically. But my point was that that chip you just saw that was only this big used to be, whoops, oh shit, I'm sorry, where my man is. Okay, so this right here, let me show you again. So this thing right here, yeah, is like what resides in this golden plate here. So if you look at the edge, you got these little golden pads. each of these golden pads would be connected by a microscopic golden wire that would ultimately go to these little pins on the ends. So you got these little needles here. And that would be like, okay, it would connect to the memory chips, or you put some input in from the, on off switches or the keyboard, and it would be like, I want to do 2 plus 2, and this would do the number crunching, and it would be like, okay, 2 plus 2 comes in over here, and the result 4 would come out over here. I'm doing a gross oversimplification, but my point is that while this chip was only literally about that big, this was a whole entire box. And basically, before they made microprocessors, all of the stuff that you see here, like if this was the registers, and this was the addition, and this was the multiplication unit, instead of it being in little corners of a silicon die, they would actually be on different circuit boards that would reside here. So just like when you build a custom computer, you open up a computer, you got all these little boards. You open this up, you got a bunch of little boards, except in this case, all they're really doing is the same thing that happened here 20 years later.
Relationship between power, size, and speed.
Well, I think the next sets of challenges that we have right now are going to be integrating video and television.
Oh, he's talking about the future. So he's saying the next set of challenges is integrating video and
voice into machines, and I think that those are beginning to happen to a reasonable degree, and maybe I can't predict whether the video disc will come in or not.
Gary Kildor, the co-host of the show, actually pioneered video discs.
Or whether that kind of how important that technology is going to be. But I think just the notion of storing pictures and operating on those pictures,
they'll never store pictures on a computer.
Herb Lechner has joined us. Herb is Vice President for Information Systems
Herb is a huge
Administration
nerd. No, he's all right.
At SRI International. Herb's got quite a background in computing. It goes back several years. I understand you programmed the ENIAC at one time.
Oh, he's old.
So, our title is Mainframes to Minis to Micros. Could you give us some idea, just for general information,
Jeff
what
Geerling covered this on his channel on some modern...
I'm not sure, Gary, that there is a precise definition, because
on some modern
yesterday's
Raspberry Pi
mainframe
CPU.
is today's micro from a performance point of view.
Oh, I see. Jeff Geerling covered this on his channel on something modern like a Raspberry Pi CPU.
Being the faster, high-end computer system that we find in scientific research.
Thanks for dropping by, KC. I appreciate the likes and Godspeed.
Which does one application at a time for one person, and somehow or the other, the minis get kind of compressed in between.
Yeah. So because Bill Gates was a cutthroat piece of shit,
three different types,
he was able to get big because this guy was just like chill and relaxed, and he thought that, oh, I could coexist with Bill Gates. It's all good, right? We could coexist and just do our own thing. And Bill was like, nah, there's not enough room for us in this town. And that was his attitude. There's not enough room in this town for the two of us type bullshit. And so, I'm going to try to not seethe with anger because I didn't really think through what I want to say about Gates. But yeah, on Lorenzo's channel, I will one day pull a recording of that time I gave a presentation about Gary and Billy Boy.
To mainframes getting out to information services, and this seems to be some sort of a coupling of the mainframe use with the microcomputers. So there's some synergism there for sure.
That's right. Some people have commented that the advent of the microcomputer is merely a spreading of the components of the mainframe system over a larger area.
Speaking of synergism, Gary, I'd be interested, maybe both of you could talk to this, because CP/M is one key factor.
CP/M is Gary's operating system that Bill Gates, well, I guess we could get into that real quick. Okay, so who wants to know the story about CP/M and DOS? Well, I'll tell it real quick. So basically, you had command line operating systems, but back in the 70s and 80s, but CP/M was unique because as the early microcomputers were coming onto the scene before IBM got in on that. So at this particular time, IBM is selling mainframes, and they're making big money off of the support contracts and all of this stuff. So they're not in any rush to, miniaturize it per se. You have mini computers, which were like the servers of their day, and microcomputers were not ready to replace mini computers yet. But hobbyists like me and maybe many of you, we wanted something we could play with at home. And as it turned out, companies were selling kits where you buy, you go to a catalog, you buy some blank circuit boards, and you solder the components that they tell you to solder. Or they might even mail you like a circuit board with all of the holes drilled into it, and they'll tell you like, okay, here's a pack of capacitors, here's an envelope full of resistors, here's an envelope full of memory chips. Now go solder them on. Or like maybe they'll say, we'll give you half the components, but you got to go find the other microchips. Maybe they're harder to come by, and you'd find them, you buy them, and you'd solder it by hand, then you'd plug everything in, and you'd have like a little bit of a computer at home where you could do mathematics, you could write some games, or you could get a catalog, and the catalog would literally have some code in there that you could literally punch into your little computer and run an app, basically. So instead of the app store, you had a catalog with code in it. And so anyway, Gary made CPM, and CPM was a lot like DOS in that it made things easier, where now you could have a floppy disk. You didn't have to mess around with paper tape. You would literally have a disk, which was a game changer. Like, disks on their own, removable disks, were just faster and easier to use, like, and just better all around. And so now you need a way to talk to that. And so it's like, well, okay, at DOS, you would literally, like, it's the same principle today, where you go to the command prompt and you basically just type in, like, okay, so I'm in my Ronald folder. So if I type dir, I have a list of files and folders. And if I want to go into the videos folder, I type cd, which means change directory. And that just means put me into a different folder. And I'm already in the Ronald folder, but now I want to go into the videos folder. So I'm going to type cd videos. And I hit enter, and now, look at that. Now it's changed. Now I'm in the videos folder. And so now when I type dir, I'm going to see a different list. And I'm going to say, oh, I want to copy this video file. So I could type copy, let's say the name of the file, from here to my E drive, like this. And let's say the E drive was a floppy disk. I just copied one file to a floppy disk. And that's like DOS in a nutshell. And this is what CPM did. The problem was that IBM had their new microcomputer, and they didn't have an operating system. So they go to Bill Gates, and Bill Gates like, oh, well, I don't have an operating system, but he allegedly said, go to Gary. And they wouldn't really give Gary a good deal, so Gary kind of like had them walk on it. They go back to Bill Gates. This time Bill Gates is like, oh, it's cool. Yeah, we got an operating system, but he really didn't have an operating system. So Bill Gates and his friend had to go find a guy in Seattle named Tim Pattison, and they basically gave the guy like $50,000 or $75,000 to buy his operating system. And then they basically licensed that operating system to IBM and made humongous money, and the rest is history. But the thing is, that version of DOS, MS-DOS and PC-DOS 1.0, which were basically synonymous, were a direct copy of QDOS. QDOS was written by Tim Pattison. Now, where does Gary come in? Where does this guy come into the story? Well, see, in order to create QDOS, Tim Pattison basically reverse engineered Gary's operating system and then passed it off as its own. That's basically in a micro, that's like in a nutshell.
Ask you, how was there?
And so bottom line is that if Gary sued in the early version, it might have worked out. Unfortunately, by the time DOS 2.0 came out, they were able to cover their tracks. And even then, there's not a direct copy of source code. That's a different topic, but the way that it was copied was essentially the guy took CPM, Tim took CPM, opened it in a debugger. A debugger shows you the code that the computer sees, the machine code. And that machine code could be turned into assembly code. And anyway, let's not go down that rabbit hole right now. But let's see what Lorenzo says here real quick. Yeah, people did appreciate things more if they had to DIY assemble it. Yeah, absolutely right. The Heath kit would definitely be quite nerdy. Yeah. So Lorenzo says, wasn't CPM kind of like a stripped down version of Unix without multitasking? Absolutely. I mean, it wasn't really Unix, but yeah, it was comparable to Unix in the most superficial sense, in that it was a command line and you had some similar commands, right? Because I mean, there's only so many ways you could design a steering wheel. But on the other hand, Unix, even in its early forms, had multitasking. In early Unix, and they have an episode about that. There is a Unix episode from the 1980s about, on Computer Chronicles. And they actually run Unix on a mini computer, and a group of kids in a university are just kind of logging into the same computer with their own command line, just like what I just showed you now. In fact, it'd be more like, Unix would be more like Linux, right? So I would go into, like this, you know, and you would have a physical, instead of having this app, you would have a physical dummy terminal. And, you know, right here, like, I have a command line right now, and I have, you know, my CPUs running, but the point is that all of the apps that are running in the background right now could be run by multiple users at the same time, and that is what Unix brought to the table, whereas CPM, you were more or less just running one app at a time. So let's keep going.
There is synergism between operating languages, operating systems, or software in general, and the evolution of hardware.
Well, I think definitely the software
different commands,
has played
Lorenzo,
a key
but some of them were
role,
similar, right?
in
CD,
the evolution of hardware.
Copy
And
was
in
the same,
that these
but then
various
make
classes
directory
of
was a little bit
machine
different.
service, I think we see that
Move was
very
a little
clearly.
bit different, but
in the
a lot of
mainframe area, the more
similar
powerful
stuff.
computers with many more peripheral devices. And in the mainframe, as classes of machine service, I think we see that very clearly. In the mainframe area, the more powerful computers with many more peripheral devices and disks and tapes.
Mainframes even today have a lot more I/O, a lot more input and output.
Will service multiple users at the same time.
See, he's saying a mainframe will service multiple users at the same time.
Software has to be massive and somewhat complex to support that. Whereas in the small side, we're seeing a trend
I believe they
towards
were running on
simpler software,
PDP-11s, but they did eventually, they did release a couple of their own machines. They
Well, I
put
think
they
also
licensed
in
it
the,
to
at least in small
HP.
computer evolution, it's been
But yeah,
sort of,
Marbell,
it's been an evolution
AT&T,
that's
they
been
created
parallels,
Unix, like
as parallel
you're
to large
pointing out.
computer systems and mini computer
They
systems
ran
to
it
a larger
on
extent.
a lot of
And I
machines.
think that nowadays there's
But
some breaking
particularly,
away from that.
PDP-11s,
Mainframe
VAX
world
11
is
780s.
many times batch or time-sharing oriented.
And then BSD
now
came
with
out.
small computer
BSD was
systems
done
are
on a
looking
VAX
at more of an
11
emphasis
780,
on, say,
but it was
real-time
definitely a
control,
derivative of Unix.
More the kinds of things you'd find in an industrial control environment or even in a home. So there is some, I think, differences there that are starting to show up.
Yes, yes.
Herb, not trying to date you, but you were with IBM.
I hope
in the
he's not trying to
50s,
date him.
The early days of this stuff. I'd just be curious, did you guys envision at that time that in the early 80s computers would be where they are right now and that we'd have made this kind of progress, this kind of evolution?
Well, I certainly didn't. And I can recall.
I looked this guy up on Facebook like 5 years ago, 8 years ago. He was still alive.
Sell 30 such systems in the entire United States market. So clearly, we did not have our sights set on the proliferation of computing we've seen today.
Well, it's interesting. Just the other day, I saw a small computer system. I can't say exactly what kind it was, but it was running PL1, and it was
his programming
the kind
language
that you can put in your briefcase. So there are definitely.
He's like, I saw a small computing system that ran my programming language. I love this guy.
Definitely has been some change in the characteristics of computers.
Look at that energy, man. That guy's like he's like jubilant like a school child. He's like, I saw this cool fucking computer and it was running this thing. It's like fucking dope.
Yeah, it's a walk down nostalgia lane to see the museum and think back to the days when we had an installation team of 17 people sent out to install a computer over a year that my kids handle in their spare time.
Okay, speaking of the newest thing, in just a moment we're going to take a look at one of the newest examples of a microcomputer, the HP 150. It's a computer where your fingers can do the talking.
Ooh, a touch screen. Yeah, the first HP Touch. We were selling we started selling HP touchscreen computers at Best
joining
Buy
us
like
now is
7 years ago.
Cyril is the
maybe
general
10 years
manager
ago.
of the personal computer
But
group.
they
at
had
Hewlett-Packard.
one
And Cyril,
in
we
the
mentioned
80s.
that the HP 150 is a good example of one of the newest.
When we set up to design the HP 150, we
there's
had
maybe a
in
lot of
mind
marketing lingo here, so I skip
professional
it.
user, but the user who is sophisticated in the use of information, but not sophisticated at all in the direct use of a computer tool. So we really focused on the computer called touchscreen capability. The fact that you can interact directly, familiar with the Rolodex on our desk. It's a set of cards and you can turn wheels back and forth until you see the right name. As an example, I can move it down just by pointing on the wheel on the screen. I can go and select a name. Let's suppose that now I have the set of names and I want to select a name there. I have Stuart.
The screen looks like something
bulky. I can just select that card. And the Rolodex opens there, and I get all the information that I have embedded in the product on Stuart.
And that one's running
his
Unix,
address,
Lorenzo.
his phone number, and so on. As a matter of fact, if what I want to do next is call him, I just...
it was very useful, but unfortunately it didn't catch on, right? The same way as, DOS had that user adoption. Businesses were confident. Now, if you were a serious business and you didn't care about, being in with the fad, then yeah, you probably would run Unix because I mean it was more robust.
Indicated I want to dial the phone.
And he's got the computer hooked up to a modem.
The modem attached to the product here.
Oh, he doesn't now, but if he did, he could dial a phone number from there, like a speed dial.
So let's go back to the Rolodex. And,
but you'd have to have a phone next to your computer.
And I can roll it down, and I can do quite a few things. You can recall, again, just by pointing the application. I can recall the specific program, what I could...
A shift from using a keyboard to using this touchscreen display. For example, we have lots and lots of applications that are written for small computer systems, and how are you going to get all those programs to move over to a touchscreen?
Okay, I think that the way we have designed the product, in fact, is by allowing very simply current and existing application to basically use a touchscreen capability. The product itself has built the ability to recognize if you are putting your finger and really selecting either a specific place where you want to put your finger on, or an area where you have your finger in that specific area. So you don't really have to burden the application itself by all that. It's really basically replacing the movement of cursor. Okay, but again, instead of having to move the cursor with your with a keyboard or with any other device, you can really point to it directly with your finger.
One of the criticisms, though, has been that holding your finger up there in your arm would be kind of tiring. In fact, I heard somebody say that there was an attachment they thought was going to come out for the HP 150, which is the little armrest. It holds your arm up there while you're touching it. Is there a problem with that, or is that just a rumor?
Well, all the studies that we have made, and we have very extensively tested the product, obviously, before we put it on the market, show that this is really not a true problem. You don't really spend a lot of time with your hands up there and pointing to the screen. I have myself a pretty good feeling that the ideal user interface, as a matter of fact, doesn't really exist. It's really going to come out of a combination and a lot of experimentation of a lot of the user interface that today exist, like touchscreen, like ability to move a cursor through a mouse or a tablet, probably one day also using voice. And I think it's going to be a combination of all those different user interfaces applied to very optimally to some specific type of application. I think there are going to be a good matching of the example. Let's suppose, in fact, I really want to go back and reselect this card. It's, again, your
He already
card,
typed in the name and all that.
I'd like to have a hard copy of that information. I'll just go and say print card, and my printer is really going to start printing that card in a couple of seconds.
The printer is on the back of the monitor.
Give it to you. The microfloppy, it's an area where we also believe there that we are kind of pushing the technology. We're using, as a matter of fact, a 3.5-inch technology, and I think that I have one in my pocket here. It is a kind of semi-rigid microfloppies. It's, as you said, different than the 5 1/4, but has today basically the same density, the same capacity as a bigger.
I wish this was a higher resolution so I could see if that was a 720 kilobyte floppy, because I'm gonna bet you it's not a 1.44 megabyte
5 1/4 disk. As time goes on, as a matter of fact, we think over the next several months, we'll see significant improvement in the capacity of those products, doubling and even quadrupling the capacity of those microfloppies, probably even getting to the range of a megabyte that you can basically carry with you. This is really the ideal, we think, personal mass storage media.
Yeah, I bet you the early Mac would use the 3.5. That would be something Steve Jobs would do, Lorenzo, right? Or he would push his engineers to work on it.
So in some sense, you never have outside contact with the
Who
media.
had a floppy disk in like junior high school where the freaking metal bit would get bent? So it'd be in your book bag and it'd get crushed. And then what would happen is the metal flap would bend out like this, or like more like, I guess if it was in the disc, it would be like that. So now when you go to pull it out, you put it in and pull it out, and the metal tab would get ripped off. Basically, like it would snag. I guess the metal thing would get bent outward and would snag as you're pulling the disc out of the floppy drive, and then you might have to use tweezers to get it out. So the floppy disks were pretty good, but they did have that weird issue.
Itself.
Herb, we've seen an example that Cyril's been showing us here of one of the newer versions of a microcomputer. Where would things be going after that? We talked with Gary at the very beginning of the show about what's the next step. It will be in the direction that Cyril mentioned of more user-friendliness.
I think that sounds about right.
What's the next stage?
I have a feeling you're right, Lorenzo. I'm not sure.
Well, I think that
sounds
there are
about
a couple of trends that we see evolving. Clearly, making the computer easier to use and
they did make
more
the Mavica floppy. Mavica mini floppies are like that big. They're the
Another
cutest
trend seems
floppy
to
disk.
be, especially in the business environment, networking the computers together. Because given your own computer and being able to do many things on that computer, it seems like this almost commands the next step as being, now let us interchange data between computer users, and we see the local area networks and networking becoming a factor.
I would agree with you on some of those points. I think that most of the networking, though, is going to be more in data communications over telephone lines.
That is a smart thing to do, Lorenzo. Yeah, keep them floppies in a sleeve.
Network throughout the whole world that is based on telephone system, and I think we're going to just see a lot more evolution in that direction. But LANs have had a lot of problems in just setting up the networks, and they're very expensive.
We got to touch upon the alien thing. He didn't say aliens, but I heard aliens.
That. I think that, in fact, we do have this network system, which is our telephone systems. I also think there is another reason, in my opinion, we're going to see this very good matching between telephone networks and computers and personal computers, is the integration of voice kind of capability.
A fun song. Alright, so yeah, that's just a little trip down memory lane. I think we'll get into the weeds on something like that some other time. I'm not going to do it exactly like this every week, but I think once in a while we're going to do this particular format. What did I... Oh yeah, so JLM, I'm glad you mentioned something interesting. I'm going to just scroll up for the chat, and we're going to find it, because you didn't say aliens per se, but you did touch upon something. Actually, you might have said aliens, but let me see if I can find it here. Okay, so, yeah, here it is. You said... I was thinking... Nope. I do wonder, you said. Right here, you said. I do wonder... He said, I do wonder about transvestites. No, I'm kidding. Okay, I'm sorry, I'm being corny. He said, I do wonder about transistors and alien spacecraft. The transistor shows up after the Area 51 events. As much as I love the extraordinary concept that we have there, I'm not sold on it. When I was a kid, I didn't know much, and I just didn't think so. But I'm gonna put forth some of my reasons why. So let me see here. So, how do we do this here? How microprocessor lift. How micro lithography. So there was like a presentation where a guy had a little girl draw like a picture on like a slide, and then he put it through a special lens, and it essentially did what they did with microfiche. And unfortunately, I'm not finding a good example right there, but
lithography.
We're gonna go take a look at, so lithography is weird. They would use like a piece of stone, and they put some ink on it. And it's sort of like an early photographic process. Trying to find a good example here.
That prepare your stone to be printed. After you've drawn your image, the stone is still sensitive to grease, and we need to desensitize the stone. By using gamma arabic and nitric acid, we will be starting the chemical process. You're applying gamma arabic onto the stone, which together with the limestone creates a layer that we call absorbed gum layer. The gamma arabic and the nitric acid will together help the grease from the drawing material get penetrated into the stone and create a greasy reservoir directly underneath your drawing.
So probably not the right rabbit hole here, but this lady's sort of explaining lithography, but as I understand it, this is how you would make copies of print. So here's an example. Remember back in the day, they would have pictures in newspapers, and it would be a photograph, but it's like, how do you go from a photograph to a black and white ink newspaper? And basically, it was a photochemical process. It was like sort of like they have an acid, and the darker parts of the image would get etched away more. And so they could take an actual photograph and transfer a black and white photograph from glass or paper to a metal plate. And then it was that metal plate that would be used for printing the newspaper. And it was a lot like developing film. So now, I guess, okay, we can make enlargements, right? Like, okay, you take a picture on 35mm film. I thought I was going to get a good example on screen, but I'm just going to explain it easily. So you get a picture on 35mm film. It's on a slide this big. Now you want to put it on paper. You want to put it in a portrait. You got to get an enlargement. So you put it under a projector, right? The projector takes that little slide, projects it on something this big, on, say, photosensitive paper, and essentially you're able to take that little slide and make a copy of it on something larger. Now, we can go from a small photograph or a small pattern and put it on something larger. We can also do the opposite. We could take a large pattern and put it on something smaller. And that's how microchips work. That's how microprocessors and microlithography works. So if we can get like maybe a picture of a CPU die like we saw earlier. So, okay, so like these are just some, like, you know, examples of the, that's a stupid research paper. I don't need, I mean, it's not stupid, but I don't want to look at a research paper right now. But, you know, you got all kinds of crap happening with lenses. And so the bottom line is these patterns, even like a regular circuit board, if you take a regular transistor board, you could actually do those by hand, and it's a matter of using like photochemicals and acid and an acid wash where you rinse it off. And essentially a printed circuit board is layers of fiberglass and copper foil. And the way to make a circuit is you literally like will draw black lines on a piece of transparent paper and put it on top of the board after treating it with chemicals. And then the parts, when you expose it to UV light, all of the parts of that board that get exposed to UV light get rinsed off. And that's why when we look at a microchip or a microprocessor, you see those little lines. Those are what's left after you rinsed it off. And microprocessors are made on the same principle. Now, when making a microprocessor, I feel like maybe we should do this on a different topic where I literally will do it properly. I'll get organized beforehand. I just want a good picture of the process, you know? So yeah, we're going to cover this. Might even cover this next week, but I definitely want to, you know, touch upon this because essentially making microchips is a lot like making a microfiche. In fact, yeah, microfiche. You know what microfiche is, right? You know, where you have those like slides that you take a newspaper and you put it onto like a little tiny slide like this. I mean, they literally took a full page from a newspaper and put it onto, in fact, that's obscenely small. Like, look at that. Those are I think those are individual pages right there. 1, 2, 3, 4, 5. Look at that. So essentially, that's how we make microchips. We basically like draw the lines or the circuits that we want on something big, and then ultimately we transfer it to something smaller. And I think they transfer it to something smaller like 3 times over before it gets onto the final piece of silicon. And just doing that means that now you have a microcircuit, a circuit that needs a lot less electricity, that generates a lot less heat, and that you could more easily mass produce. And this gave way to like microcomputers, which are technically desktop computers, are microcomputers. Both desktop computers, laptops, and mobile devices are all technically microcomputers because they heavily rely on microcircuits, integrated circuits, and microprocessors. The exception would be that as you get to newer processor chips, they might take like a hard drive controller and put it inside a CPU, or a memory controller and put it in a CPU. So now instead of having 2 chips, they're on 1 chip, and that's going to make the communication between the 2 devices faster, or components, and it's going to reduce their power consumption. It's always going to make it easier to produce. And on the phones, they got what they call SoC, system on a chip, where you'll literally have the processor, the video chip, the sound chip, the USB ports, and whatever other crap, all on a single chip. And that's like when you look at the specs for the iPad, you're going to see something called a SoC, system on a chip, and that's what we're dealing with. But I know that the rapid advancement since the 40s seems like so fast that it must be the result of, you know, the stuff that happened in Roswell and whatnot. And I get that, you know, but I think it's much simpler to attribute to these very processes. But let's catch up with the chat here. Yeah, Memorex was a popular floppy disk brand. I remember them, and I bought a lot of their DVDs. Sony manufactured 3.5 discs as well. Colonel Morg says Memorex is a term I've not heard since well before most people were born. Yeah, I remember like it was sort of like Xerox for a while, where it says, "Oh, we need to get some Xeroxes," which really was just like, the generic term was making a photocopy, but the originator that invented it became the basically everyone ended up using the name of the original company as the name of the thing itself, even though, of course, no other company was allowed to say, "Oh, yeah, we make a Xerox machine." No, a Xerox machine is Xerox Inc., but essentially any company, Motorola can make a copy machine, and people would still be like, "Oh, I need to get some Xeroxes." Moving along here, Lorenzo says, "I believe Memorex used to make cassette tapes." Yeah. Wasn't it a slogan, "Is it live or is it Memorex?" Was it them or Maxell? I think it was Memorex. I think you're right. But I know Maxell was big on tapes, right? And, Colonel Morgan remembers that, most likely remembers that. Yeah, microfiche is really great. I think it still exists in some capacity. I mean, certainly, look, this is EMP proof right here, right? I mean, as long as you have some kind of, like, glass or optical lenses and light sources, these work. You could fit, like, a lot more of these microfiches on, like, so you could have, like, a USB flash drive that should be able to store all of these and more on maybe like a micro SD card. But micro SD cards go bad at random sometimes. Like, sure, you can make 10 copies of the same SD card, but if shit really happens, the right solar storm or EMP, that's still kind of wiped out. So I sometimes think about, I looked into backing up data to paper. There's actually a standard. It's called Twibright Optar, and it's like, imagine printing QR barcodes on printer paper, and it yielded like a quarter megabyte. I don't know how much. It was a very small, like hundreds of kilobytes per page. So if you could do multiple pages, you could literally store multiple files on a stack of paper, but you have to literally scan it on a scanner and use a program to convert it back into a file. So it was cumbersome, but it was a fascinating idea, like as a potential solution to backing up data on something that was impervious. But I think it's just easier to make a Faraday cage. So moving on here, there was a microfiche and a microfilm from what I recall. I don't know the difference. I just thought they were the same thing, but I really don't know. There might be a major difference. Maybe microfilm serves a different purpose. Maybe microfiche is for newspapers. I don't know. Maxell makes hard drives now. Not that I'm aware of, but a lot of times companies get bought out by other companies, and there may be some overlap there. And interesting. Colonel Morgan says, "We were still using microfiche in the office in the late 90s, but then mostly everything got scanned and the old machines were taken away." So, I mean, like, I can understand not wanting to keep the bulky machine. That's like every public library. But it would be wise to keep a few around. I mean, the Library of Congress, they have archives of this crap that has not been digitized. And so I'm certain they have the machines. But the Library of Congress was interesting. It was like those lucky government workers who get overpaid probably, like, they pretty much have these custom scanning machines where, like, basically it's a camera above a glass panel. You take like an old ass book that's this big, you lay it down flat, you put the glass panel on top of the old book with the pages open, you take a picture of it, and then they process it or whatever, and you get like, it's a quality scan. But that's how they can scan unusually sized documents. So if you get like a Nazi propaganda poster from World War II and you want to preserve that, you put it on that large top down scanner, so to speak. But bottom line is that there is a history there. It's something that I did not prepare to cover tonight, but I'm really glad that JLM brought it up, because I think next time I do something like this, instead of going and seething hatred about Bill Gates and CPM and how Gary Kildall is the fucking man, because he is, and how Bill Gates basically contributed to that man's death, and maybe indirectly because man ended up drinking a lot. Look, when you get screwed by Bill Gates, you tend to drink a bit more, right? On the other hand, some people speculate something more nefarious. I mean, there's like 3 versions of how Gary Kildall died, and that alone sort of caused things into suspicion. When I was on Lorenzo's stream talking about the story of, how Gary got screwed by Bill, so to speak, we touched upon how there's 3 versions of that story, where Bill Gates will go around saying, "Oh, Gary was jerking around, joyriding in his airplane." And then Gary's best friend's like, no, he was delivering software to a client. You know, and like there's like 3 versions of that story. But of course, Bill Gates will stand by that version of the story that makes Gary sound like the slacking piece of shit, because it definitely serves his interest. You know, Bill Gates definitely shows evidence of favoring the self-serving version of that story. And in the documentaries on PBS where they cover that version of the story, I can almost certainly assure you that Bill Gates, that was preceded by Bill Gates donating money to those PBS networks. But this is all speculative, and this is not the opinion of this YouTube channel. Do your own research, or I really need to come up with a disclaimer, so I'll work on making a proper disclaimer. But yeah, I really don't think it's Roswell. Like, it's literally, I can't say it enough times. I'll say it one more time. And I'm not saying it one more time because I'm exasperated. I just want to make it clear because I know it can meander a lot. Yeah, microprocessors are basically microfiche on silicon. That is how I would put it. And, you know, I don't blame someone for not knowing how the process works. One YouTube channel, that's what I would do, is as a takeaway, there is a YouTube channel called Asianometry. And this guy, like right here, like etch lithography's unheralded sibling, or Canon's nano imprint lithography, or TSMC, one of the Taiwanese companies that do all this work, the end of American lithography. And somewhere in here, there's like an early history of lithography. And this guy will go into the weeds. He'll show you the machines that went into making this stuff.
Tech stepper.
The UV light, which has a smaller wavelength so that they can make smaller circuits. And it is definitely like a lot of complexity. But everything that we develop is iterative. Oh, excuse me, I had a hiccup. Iterative in that it's like they figure out one simple thing and they build, there we go, the photo mask. So I would say this is recommended reading, like for anyone who has any curiosity.
One of 3 critical parts in a photolithography system. Can you guess the other 2?
We're going to just put this into the
I'll
chat
give you
here.
a minute or so to think
I'm going to
about
put the title here.
Anyway, the master image with a
So
chip
this is the
design
history of the
or
photo
part
mask.
of a chip design.
And
As a fundamental part of the lithography
see if we can
puzzle, it
skip
has
through
a
it real quick.
fascinating history that goes all the way back to the very beginning. So in this video, we're going to look at this essential piece
See
of the
right there, see those
semiconductor
ladies there? They're basically like sketching it out or making a photo mask that is going to go towards making a microprocessor.
The resist. The resist reacts to the light so that a chip pattern gets printed onto the wafer. After that, the pattern can then be etched in using further processes. Back in the earliest days, like the 1960s,
The earliest days, so this is like, I'm not going to cover this whole video, I just want to share, this is relevant right here to the topic at hand.
or so, people used a method called contact printing to make integrated circuits. This very crude and simple method was used for making chips with feature sizes of about 200 micrometers. Making a photomask in those days was as much kindergarten arts and crafts as it was a science.
It was as much kindergarten arts and crafts as it was a science to make these photo masks in the early days.
You first start with a hand-drawn circuit design on graph paper.
A hand-drawn circuit design on graph paper.
To enhance the design's precision, you would draw it up at a much larger scale than the final actual size, say 50, 200, or even 500 times. Then you have to cut that design onto a special type of 2-layer photographic film called RubyLith. RubyLith has 2 layers, a light-blocking red film laminated to a second layer of polymer, usually mylar or something. You use a knife to scrape away the RubyLith's softer red layer, leaving the clear polymer layer behind. This was delicate work.
So they're taking a hand drawing and they're putting this RubyLith or ruby tape on top of it, and then these girls are practically using X-Acto knives to pick away at it based on like almost like tracing paper.
And because the designs were often so large, cutters had to be mindful of their sharp toenails when they climbed all over the tables. Fresh socks were considered essential. The completed RubyLith design was often referred to as an artwork. RubyLith itself was originally developed by the Ulano company for screen printing and the graphic arts. And in fact, this whole method comes out of the printing industry. The semiconductor industry adopted it for their own nefarious purposes. So, it's kind of interesting to think about the shared technical ancestors between a leading-edge Apple M2 chip and your average screen-printed shirt. The next step would then be to reduce the artwork down from its 500 times scale lit with a mercury lamp onto a photographic glass plate. You would then end up with a 10x reticle, which contains a small piece of your final mask. I love the German phrase for it, though I obviously can't pronounce it. Schweichennegative. At this point, the reticle is still about 10x the size of its
so right there, that's still 10 times the size of what you're working on.
Final intended size. You need to arrange many reticles in a repeating pattern onto a single one-time sized master mask. In 1961, a company called David Mann introduced a tool called a photo repeater. It does two things. First, it reduces the reticle to its final size. Second, it prints the reticle's design onto a glass substrate slowly, step by step. This step and repeat camera, as it was called, is the technical precursor to today's wafer steppers. The master mask is directly in contact with the resist-coated wafer. You press a mask hard against the wafer in a vacuum so to get good contact and avoid any flatness errors. Sophisticated metrology tools did not exist back then, like at all to be honest. People looked for errors with a steel measuring tool and a 10x magnifying eye loupe like those used by jewelers. The industry realized that they needed new technologies to improve throughput and accuracy. One of the first improvements they added was a tool called a coordinatograph, which was borrowed from cartography and kind of looks like a light table. It mechanically adds stops in the X and Y axis so to help guide your hand in both the direction and length of the rubylith cut.
So you see how this has a lot of origins in photography, sort of like how I was making these analogies between microfiche and photo film. And this guy's bringing up the printing industry, and we're literally seeing it in action. We're seeing some of we're definitely skipping through it, but we're getting an idea of how this was a manual labor at one time.
Need to manually draw the design as well as the intermediate closures and no more. This was not economically sustainable. To lengthen a working mask's working life, the industry swapped out the materials from soft groups to hard, more persistent metals like iron and chromium. This worked, but only to a certain extent. So what do? You remove the contact variable entirely. That is what the Perkin-Elmer Corporation did in
Perkin-Elmer, they're the company that made the mirror for the Hubble Space Telescope that, was messed up. But because they did a precise job at making a mistake on that mirror, they were able to fix the Hubble Space Telescope. So in a way, despite Perkin-Elmer fucking up on the Hubble Space Telescope's mirror, their fuck up was done in a well-documented and precise manner that made it possible to fix the issue. So I gotta give him credit. But what this guy's saying is that at one time, they would do the hand-drawn rubylith, right? And they would make copies and transfer it. And ultimately, you'd have to basically press one to the other in order to basically transfer the pattern. But let's say this rubylith or this master pattern can only be used 20 times. I need to make 1,000 chips, so that means that now I gotta make 200 of these fucking handmade things or whatever the hell they are. And so anything you could do to extend the useful life of that would make it more economical to make these microprocessors. And so ultimately at this point, this guy's talking about how they basically eliminated the physical contact and made it more like projecting light, basically, like microfiche.
The microline.
He does a video on Japan.
Exactly. So GCA, Nikon, and Canon built on the aforementioned step and repeat cameras.
Nikon and Canon were big on this.
Is now transmissive with light passing through it. We have to worry a lot more now about keeping particles away from it.
Yeah, talking about how basically this is the beginning of the clean room environment. So now you got this thing that projects light, but now it's more susceptible when particles are blocking the light, and basically you could ruin your microcircuit with a piece of dust, basically. And it starts to get so obscenely complex that if you look at a machine, a modern machine today, it looks obscenely complex. This EUV machine, look at that freaking monster right there. That's just one picture of this stupid machine, but holy cow, right? So I get why it looks obscenely, but the goal is basically to project the image onto a silicon wafer, or this is actually just a mirror right here, but this machine has multiple steps, and this guy in the video talks about how when they were shipping this machine, or a machine like it, it bumped into something, and basically as they were trying to put it in the facility, in the clean room, they're like, ah shit, we bumped into something. And they had to send it back to the fucking company for $250,000 or some shit, maybe maybe more, maybe millions of dollars to have it recalibrated. Because of course, if you bump into something while trying to put the machine on the floor, you might have a mirror that's out of alignment. You might have a prism that's out of fucking calibration, and this fucks up the yield. So yeah, they had to return the machine to get it fixed before I could get it delivered again. There was no way to do these like adjustments on premises, basically. So yeah, it's a monster of a machine, no doubt about it. And then, you know, they use different types of light. UV is sort of what promises that the wavelength will help us get even smaller circuits. But yeah, so some of what I want to share. So I hope that's like a little more enlightening. Oh, that's cool. It's a microphage. That looks kind of cool. But yeah, if anybody has any thoughts, questions, comments, or anything, please say so in the chat now. Speak now or forever hold your peace. Otherwise, I am going to take a moment to prep my Gundam for work tomorrow. Because tomorrow is a holiday. Tomorrow is election day. Okay, I'm sorry. It was part of my dirty jokes. But jokes aside, so I got this cool new light, but it's freaking huge, so I can't put it down anymore without blocking my head. But what I need to do is I need to pack my Gundam for work tomorrow. So I got the RX-78-2, and I built like most of it, as you can see, right? It looks pretty good. It's missing some armor. So I have most of the pieces here, and basically my goal is to bring this bad boy to work tomorrow, because it'll be a quiet day with no managers, and I'm going to continue my work on my Gundam. Hey, what up, Tommy and the Guinea Pig Collective? Yeah, and this is not the Victory Gundam. I'm still working on that big one with the, you know, with all the really cool features, but that's also a consideration. Now, I'm not going to work on the Gundam shield. I'm not even going to do any painting at work tomorrow. I want to spend some time painting, but I don't know. I think like the painting is a bit of a fool's errand sometimes, especially when like, you know, you have all these little issues with getting the paint to be even, and dealing with the paintbrush and the quality, and me wasting tons and tons of rubbing alcohol. I'm looking for my modeling glue here, because this is how we get rid of panel lines if we want to get rid of them. You know, I take it back. I'm taking the Gundam shields into work tomorrow. I'm going to possibly try to fix it up. So we got our Gundam. Let's see here. I'm trying to see what else I'm forgetting here. But yeah, this is like a pretty decently featured, you know, Gundam construction kit right here for work, you know. I did misplace some of my material, but I learned how to use one of the Gundam markers today that I didn't know how to use properly, so that was kind of cool. Gotta bring in the cutting tool, that's vital. There we go, there's our paint markers. What else are we missing here? I should bring maybe a few Q-tips, in fact. Yeah, let's bring a bunch of Q-tips. Let's bring a shit ton of them. I got more downstairs somewhere, so there we go. Okay, we got different grit sandpaper. Do we need an X-Acto knife? Maybe not, but I might pack one anyway. I feel like, oh yeah, here we go. Some more Gundam parts right here. These are vital. We definitely need these. But yeah, good to see you, Tommy, and the Guinea Pig Collective. I don't know how long you were here, but what we did was JLM mentioned something about microprocessors and aliens, and so usually like when somebody insists hardcore, like, oh, it's definitely aliens, I get like pretty much like, oh yeah. But JLM is my friend, so I didn't give him a hard time about it. But I was like, I ended up like, you know, going down that rabbit hole for like a couple of minutes just to kind of, you know, try to provide evidence that it's not exactly aliens or anything like that. But I can see where people are coming from on that angle. I just like, I think that no, it's very much homegrown, very Earth type, very human, earthly technology right there, you know. Am I forgetting anything? I think we got everything here. I got my transforming Victory Gundam here. I'm not going to transform it because I'm going to break it if I keep trying to transform it. I'm just double checking if I'm missing any pieces. We basically got everything we need. I can work on the beam rifle if I want. So yeah, like, if there's no other questions, it's a shame that so many more people are showing up, but yeah, we are wrapping up, because it is a school night, even though it's election night, and I don't really have to wrap it up, I guess. Right? I mean, like, my manager's not going to be in tomorrow, so I guess I could do what I want. I got to dress my turtle up. I made a burlap, the Yoda costume for my turtle right here, or for one of my turtles. I got to pick one of the turtles to wear it. It'll probably be Squirtle, because she's a bit more cooperative. But you see, we got like all of this here. We got like we're ready for work tomorrow. Look at that. I can build a Gundam, and I got like different tools. I got different files. I am misplacing some of my sandpapers, but I don't need them all. But I hope I find the one that I really like. But I'll look for that after stream. So yeah. Anyway, I think we covered a lot of ground today. And Tommy says, I'm so lucky I have no time schedule. On the other hand, not having a schedule is messing me up. Yeah, I know what you mean, man. I've been there. Right now, so I'm on a 3-day 12 or 13 hour schedule. But it's like, after that, I'm basically a free man, right? So it's like, I sort of behave like I'm on vacation. And the only problem is that by Saturday night, I'm waking up so late, Saturday morning or Saturday afternoon or whatever, that I have trouble sleeping on Saturday night. And then, you know, by the time I go through the cycle again, I'm tired on Tuesday, I get a good night's sleep, and then I reset the cycle again, you know. So I should probably get some better sleep habits on my end. That's definitely more of a discipline thing, but I do enjoy having that ability to have this cool schedule, you know. So yeah, you know, and I think we covered everything here. So yeah, check out, if you want to stream, if you want to look at mainframes, minis, and microcomputers, go and search Computer Chronicles and look at the episode about mainframes, mini computers, and micros. If you want to see, you know, what we were talking about earlier in the stream, you literally go on YouTube search and type in Computer Chronicles, like straight up like this. And the episodes from the 90s are like nostalgic as hell, but like, you know, you just go to the YouTube channel Computer Chronicles, and if we go by decade, 1983, the first episode is about mainframes and whatnot and mini computers. But you can see here we got an episode from like 1990, right here. This is like 1993. It's an episode about the internet, you know. And I remember these 90s episodes of Computer Chronicles like started having this like interesting vibe, especially as you get to 1995 and 1997.
Linear digital approach.
Similar problems.
So, you know, all that nerd stuff. So yeah, that's that. So anyway, I want to thank Lorenzo Sleestack for dropping in. It's great to see you, man. You know, I always enjoy your show, and I'm glad that I get to see you on my ground, on my turf this time. Nah, but jokes aside, it was good seeing you. Lady Mist, thank you very much for dropping by. Tommy and the Guinea Pig Collective, also good. I think Tommy has a stream tomorrow night. I'm gonna guess that Tommy has a stream tomorrow night. I don't actually know. I am an agent of chaos, Tommy. But I bet you if I go and I click on live streams, it'll say Nibbling Live. Yeah, at 7 p.m., I believe. And we're going to pop a link into the chat for that. So, guys, you know, go to Tommy's channel. And, you know, is that 7 p.m. Eastern time? I think it's Eastern time. And so, you know, click the notify button if you want to tune into Tommy's show tomorrow at 7. It literally happens like an hour before I get off work. In fact, a half hour before I get off work is around the time that Tommy's stream starts. So it's like a part of basically my Tuesday wind down routine. And we already got some cool people in the chat. We got Orville Nation. We got my boy Bone. I don't know if I know Chaos Hoy, but I like the concept of chaos. So it's all right in my book right there. So yeah, it should be a real bang up time. They do a lot of cool toy reviews and discussion, and sometimes you see some really cool toys that you get envious about, and then you have to decide if you want to spend like hundreds of dollars on them. And of course, I want to give a shout out to my favorite mod, JLM. And we had that girl Casey here earlier. We had QEPX, which he was good today. Oh, he did ask to be mod today. Okay, I was gonna say QEPX did not ask to be mod today, but he did. He always does that. That's sort of his thing. And I think we covered everything. Also subscribe to Lorenzo, you know, especially if you want to get in on that open stream that he often does on an almost weekly basis. Cool. Oh, that's good that you follow both those guys, Lorenzo. So anyway, for real, for anybody watching on the replay, if you have any questions, comments, or ideas, please leave a comment. Please like and subscribe. And for now, we shall end transmission as soon as I hit this button.